Good morning, all. Today we are going to start the fifth module of your syllabus, Interprocess Communication and Synchronization. And in this session, we will study about process and thread from that module. These are the topic which we will cover in this session. Initially, we will study about the process and various state of the process. Then we will move on to thread, and we will discuss about different type of thread and multi-threading. You may already familiar with the term program. A program is a set of instructions which is written in any of the programming languages, and it is used to perform some task. After writing the program, you have to compile the program to make an executable. And when the executable start running, we will call it as a process. In other words, when the CPU start executing the program, we call it as a process. Now let's go through the memory footprint of a process. And for every process, the OS will allocate some memory. And this memory contains a stack section, and this stack section is used for storing variables, and it is growing downwards. It means that for the new variable, the lower address space is used, and for newest variable, again lower address space of the stack is used. And for dynamically allocated data, we can use a heap memory, and this heap memory is growing upwards, and this heap memory can be allocated using malloc or malloc and dalloc function in C. And for storing uninitialized data, we have a BSS section, and for storing initialized data and test, we have some memory locations, and the topmost memory location is used for command line arguments and environmental variables. A process is a program under execution. So depending on the execution, a process has 5 execution states. First is new state. When a process is created, the state of the process is called new state. And after creation of the process, when the process started execution, we can call it as it is in running state. And suppose if the process needs some external resources, that time process is in a halt state for waiting for some external resources, and in such cases we can call that the process is in waiting state. And if the external resources is available, so the process want to re-execute again. Such times we can call it as it is in ready state, so that the process is waiting to be assigned to a processor. And after completion of the program, we call it as process is in terminated state. When a process is created, it will be in new state, and when necessary resources is allocated, it will admitted to ready state, and from the ready state, it will go to running state by assigned to a running state by a scheduler using some scheduling algorithm. So it will be during the runtime, it will be in running state, and after at running state, if the process requested some resources and it is not available presently, it will goes to waiting state, and it will stay in waiting state till the resource is allocated. And when the resources is allocated, and it will goes to ready state, and from the ready state, it will go to running state depending on the scheduler algorithm. and at running state it can either goes to terminated state if the program exits. When a process is created, the operating system will allocate some memory for storing all the information related to the process, and this is called a process control block. And this process control block is used to manage the process. So here in a process control block we can see there is a one process ID, and this process ID is unique to all the process. So using this process ID we can identify and manage the process. And there is one process state, and this process state contain present state of the process, such as running state or ready state or waiting state, like that. And then it is process priority, and this process priority is information is used by the scheduler for scheduling the process. And there is one accounting information. This accounting information contain about the information about the time, how much time the process is executed, and how much memory it is using, like that. And this accounting information is also used by the scheduler. And then it is comes process program counter, and this program counter contain the contain the pointer location of the next instruction to be executed. Then it also contain CPU registers. And when a process changing from running state to waiting state, it will store all the processor registers in this memory location. And using this register, and when the process come back to the running state, this CPU register value will be reloaded into the CPU for starting the execution from it is left off. And it also contains some PCB pointers. You can use a computer for multiple tasks. For example, you can download a file. At the same time, you can do a word processing application, and in the background you can hear a song. And you are thinking that all three applications are running simultaneously, but it is not the case. These three applications, like downloader applications, word processor application, and audio player applications, are running in a time multiplexed manner using a scheduler. And this, in order to schedule this task in a time multiplexed manner, we need a scheduling queue. And there are three types of scheduling queues. First one is job queue. Here you can see all the process in the system. Then ready queue, and here all the process, here you can see all the set of all process residing in the memory and ready and waiting to execute. Then there is one other queue also, which is device queue, and here you can see all the process which is waiting for an IO device. This is the diagram of scheduling queue. Here in the job queue you can see all the process, and if the process is ready, you can see all the process which is ready to be executed in the ready queue, and it is ready to given to CPU by scheduler. And if the process is waiting for some IO devices, then you can see in IO waiting queue. This is the model of process execution. Initially process will be at the ready queue. Here here in the ready queue contain a list of all process which want to be executed, and depending on the process priority and process accounting information, the scheduler will assign the process to a CPU, and if at this CPU the process will start running. And when the process requested some IO resources, it will goes to a waiting stage. Here it will wait for IO resources to allocate. When the IO resources allocated, it will again goes to ready state, and after termination of the program, it will goes to terminating state. A process can be created using fork system call. This fork system call will create a new process, and it will return the process ID of the new process to the original process. And this original process is called parent process, and the created process is called child process. And this parent process can manage the child process using the process ID, which is returned during the fork system call. And this parent process and child process share some common resources. And also the parent process and child process is executing simultaneously. And for normal operation, firstly the child process will exit, then the parent process will exit. If the parent process is terminated first, then the child process become an orphan process. This is the diagram of the process creation. Initially, we will create new process using fork system call. After fork system call, we will get a new child process. And this new child process and parent process both are executing simultaneously. And when the parent process completed its execution, it will wait for child process to exit. And after child process executing the program, child process will exit. So it will combine together and resume the operation. A process can be terminated in two ways. In the first method, the process will execute a system called exit. And upon executing this system call, the operating system will deallocate all the resources which is allocated to the process, and it will terminate the process. And sometimes parent process need to terminate the child process, and such times the parent process can use the abort system call, and this system call will deallocate all the resources which are allocated to the child process and terminate the child process. And this abort system call can be used in some cases, such as the child has exceeded the allocated resource, or the task assigned to the child process is no longer needed, or if the parent process is exiting, the child process also need to be exited. So in these three cases, the parent process can use the abort system call to terminate the child process. In the last few slides, we have studied about process. A program in execution is called a process. Then we move on to various states of process, such as new state, ready state, running state, etc. Then we have studied about various methods for creating and terminating the process. Now we are moving on to thread. A thread can be considered as a lightweight process, and it is more like a subunit of a process, so that each process has at least one thread, and sometimes the process may have multiple threads. And in order to identify the thread contain a thread ID field, and using this thread ID we can identify thread, because this thread ID is unique to every thread. And along with this thread ID, the thread contain a program counter, registers and stack, and the program counter store the pointer location of the next instruction to be executed, and the registers contain the various CPU register value at the last execution time. and it also contains various variable for execution of the thread. And thread share same code section and data section and operating system resources of a process. So during the creation of the thread, the operating system need not to create extra code section and data section for this thread. So the operating system can create and manage the thread very easily. Along with the thread ID, thread also contains the execution state, and this will tell whether the thread is in running or thread is in ready state, etc. And thread also contains context and then execution stack, and then there are some local variables which is unique to the thread, and also contain memory resources of the processor such as shared data and test section, shared code section, etc. and some other operating system resources such as open file and signals, etc. Thread has many advantages and disadvantages. Firstly, we can go through the advantages. We know that threads under a process share common data structures, global variables, and child process. So the threads can be communicate each other with the help of this global variables and data structures. And so in order to communicate with this each other, we do not need to use the system call. So the communication will be faster and efficient. And also thread can be created and terminated easily because the thread share common data structures of the parent. So the operating system need not to recreate the data structures for creating a thread. So the thread can be easily created. And thread also help to improve the parallelism and overall performance. And the main disadvantages of the thread is that this thread share the open files and data structures and global variables. So there is no protection for accessing these data structures and variables. There are two types of thread, user thread and kernel thread. User thread is created and maintained by the user or user program. Here the programmer uses some threading libraries to create this user thread. And the operating system doesn't have any idea about the user thread. And the second one is the kernel thread. The kernel thread is created and maintained by the kernel. And for creating this kernel thread, the programmer use some system calls in the programs to execute or create this kernel thread. And since it is managed by the kernel have full understanding of this kernel thread. So the kernel can easily parallelize the thread in a multi-core system. The user thread and the kernel thread can be understood by this diagram. Here you can see that the first one is a completely user thread program. There is no kernel thread. And here in the second diagram you can see it is entirely kernel thread. No user thread is created here. And in the first diagram, the top portion is the user space and bottom portion of the kernel space. And the thread is created at the user space. So kernel doesn't have any knowledge about this thread. So kernel think the entire program as a single thread. And in this case, the kernel created 3 threads for the process. And kernel managed 3 processes in their kernel space. So in order to access these threads, the user need to call system calls to modify and access the thread which is created in the kernel space. Now we can go through the user thread and kernel thread characteristics. The user thread or user level thread are easier and faster to create than kernel level thread. And user thread is easily manageable also. And for creating a kernel level thread, we need to execute a system call. And it will take more time than user thread creation. But the advantages of this kernel thread is that we can assign each kernel thread to a different processor in a multi-core system. So each processor can run each thread in a parallel fashion. So we will get a higher speed compared to the user thread. We can see the difference between user level thread and a kernel level thread. The user level thread is managed by the application, but in the case of kernel thread, it is managed by the kernel. And in user thread, the kernel is not aware that the user thread is running. And also context switching is done in the case of user level thread is very cheap. But in the case of kernel level thread, context switching done by the kernel and it is more CPU intensive. And there should be a limit on the number of kernel level thread we can be created. A kernel thread can be created with the help of a system call. Here in C language, we can create a thread using pthread create function. Here you can see there is a master thread and it is called a pthread create function. Upon calling this pthread create function, it will generate worker thread and this worker thread will do its work. And in the same time, pthread and the master thread also do its work and it will wait for the worker thread to be closed. And when the worker thread run a pthread exit function, it will close and combine, both thread will be combined together and continue the execution. Now we can go through the multi-threading concept. A multi-threading is the ability of the CPU to provide multiple threads of execution concurrently. Now we are moving on to single-threaded and multi-threaded process. And here you can see there are two processes, process 1 and process 2. And this process 1 is a single-threaded process and process 2 is a multi-threaded process. And you can easily identify the difference between single-threaded process and multi-threaded process from this image. Here you can see that in multi-threaded process there are multiple thread which is associated with a single process. But in the case of single-threaded process, only one thread is associated with a single process. And in order to execute a thread should have code section, data section, file section, and registers and stack sections are needed. But in the case of multi-threaded process, each threads in the same process share same code, data, and file section. But the registers and stack section need to be recreated for each thread. So the operating system can easily manage the thread without need to replicating the code, data, and file section of the process. These are the benefits of multi-threaded programming. The first benefit of the multi-threaded programming is improved throughput. It means that if you are using multi-threaded programs, then it may be possible that each thread of the program may be executing in different processor simultaneously. So we will get a higher throughput than single-threaded programming. And it also improves the application responsiveness. Suppose if we consider a web browser, and in the web browser there may be some thread which is handling the download operation and there may be some thread which is handling the browsing operation. And if the downloader thread went to a halt state, the browsing will not be affected. The application so remain in a responsive state. And it also improves server responsiveness, because in a multi-threaded programming, all the task done by the server is handled using multiple thread. So if the one thread is get loaded, other thread can also work smoothly. So it will improve the responsiveness of the server. And it also minimize system resource usage, and it improve the program structure simplification. So the program structure simplification help the programmer to develop efficiently and faster, and also help to debug the program easily. And multi-threaded programming also gives higher communication than single-threaded programming, because multi-thread and each thread in the multi-threaded program share the resources, so we can easily communicate data between each threads. Thank you.